the use of identified conductors. Now remember, in the code book, when we say the word identified, it actually means white. I use my white marker there. Pretty awesome. So why is this important? Well, it's really important that you're aware of a few different rules in section 4, and specifically to do with cable installations. Cable installations are important because typically a manufacturer will produce a cable with a set number of conductors in it, and those conductors pre-colored. So you might have red, black, and white. Red, black, and white out the other end. Or you might have red, black, blue. But man, what if you have a circuit that requires different colors? Are you prohibited from using this cable here for a three-phase system that requires red, black, and blue? I mean, that would be kind of ridiculous if you couldn't use this cable in some way. What a waste of resources. And so what 4022 and 403 go to clarify is, when can we adjust the manufactured coloring of a cable? And what can a white conductor actually be used for? Remember, this is not a discussion for conduit, because conduit, well, conduit, you decide the conductors that go inside. So if you need 3 black conductors or 2 black and a red, you pull in those specific colors into the conduit. You do not utilize a white conductor and then face tape it, because that wouldn't make any sense. So conduit is a different discussion that really is a little bit more simplified, because you don't need to worry about this. All right, so that aside, let's take a look at these two rules, 4022 and 4030. 4022 is simply telling you that an identified conductor needs to be brought into every single box and fitting that the main circuit conductors go into. And there was an additional subrule added there. You look at the last subrule of 4022, and it brings up a very common installation that we would have with cable and lighting. Notice in that new subrule at the very bottom of 4022, it says, in permanently installed lighting installations, you must have an identified conductor going to the switching outlet. And so what this introduces is some challenges with some older installations. So previous to 2018, what I'm going to show you here was a very common installation for lighting. You would have a black and a white going back to your panel as your home run, and then depending on the orientation of what object was closer to the panel or what just made sense logistically, you could bring the power feed to the lighting box. The lighting box would be up here. And the white conductor would terminate at the light. The black conductor would have to then splice, and it would splice through the white to the switch, and then the black would come back and terminate to the light. So it would work. It would work, and it was logical, and that functioned well as long as you knew what was happening with the conductors. However, now, if you wanted to put a smart device in here, some form of a smart Wi-Fi operated light switch with a computer inside of some sort, if you wanted that to function, it had a little touch display and a little, I don't know, box, I don't know, something fancy, you would need an identified conductor. And at this point, we do not have an identified available here. Remember, this white conductor is not really an identified, is it? It's actually connected back to the hot conductor, which goes all the way back to the panel. And so anything like this, a smart light switch, would require an identified to function. And because the Internet of Things continues to grow, and provinces have even allowed for some installations to go ahead without any hardwired lighting switches, but it's all wireless control, you would then need to have some form of an identified at every location where there is a switch. So what then else could we expect to see in an older Installation? Well, let's first look at how this is now required to be wired. Now, if we want to do this installation, we have to bring the hot and the home run, essentially, to the switching outlet first. So there's our black, there's our white, and we know that is going to moret into the white of this cable, and then we have the black and the white. So this is from 2018 and on. We would have to do this installation in this method. You have to have an identified present at the switching location. Now, is there any situation where you would be able to do the previous diagram? Like, remember the one that I showed before? He said we had that switch in the middle of nowhere, and it's called a dead end switch. Well, notice 4022 simply says lighting. So here's an installation that's pretty common in residential. This is a carburetor. There's a dead fish going into the carburetor. And what you have is the same situation as what we did previously in lighting, but this is okay. This is permitted to do because the rule simply states for lighting. So here's my black and my white going back to the panel, right? And from there, we have our black and our white, and I'm just gonna pretend that the box is inside here at the carburetor, but my white is gonna have to terminate to the circuit connection inside the carburetor, and my black is gonna moret to the white of this conductor here. And remember, this conductor is gonna go to the switch, it's gonna go back and terminate at the carburetor in order to facilitate operation. So something like this is actually permitted. You are permitted to do this. And so it's important to realize that these distinctions come up between old and new code. Well, let's then look at 4030 because 4030 really is what tells me how to do this connection here. 4030 discusses how we can use the identified with a cable. And this connection here between the black and the white is outlined in that rule. It discusses switching loops. And what they say with this connection is that you have to ensure that the return conductor is not the identified, as in it has to be a colored conductor. So important to see that. Okay, well, what else then would we have the option of doing with an identified conductor in a cable? Because that's sort of how we introduced the whole concept. We said sometimes you're going to run into situations where you have a cable, but the cable doesn't match the coloring that's required by the CEC. So remember, the coloring of conductors is listed in section 4032. So section 4, or rule 4032, is identification of insulated conductors. If my conductor coloring doesn't match what's given in 4032, then I need to either pull in new conductors or take a look at 4030. So I'm going to write 4030 at the top here. 4030, what do we have? Well, this is a 240 volt circuit, and we've got some 14.2BX, and we've got a heater that's rated for 240 volts. I'm using a black and a white conductor in my 14.2BX, and let's assume that obviously my conductor size has been sized appropriately for the size of the heater, and really the only problem I'm having is in regards to the coloring. So let's take a look at 4030 and see what we're permitted to do. So I'm going to look at 4030 subrule 1. So this is subrule 1 that we are going to look at for this first example. It says that we can utilize the identified conductor for something other than what it would originally have been designated for, as long as everywhere that we see the conductor exposed, it has been rendered permanently unidentifiable. What is permanently unidentifiable mean? Well, in reality, it would mean painting it. But for most of us, we know that we're going to use phase tape. And you could then phase tape it red because the color coding for a 240-volt circuit is red and black. So red phase tape would really be the alternative here. So I phase tape the white conductor red. And what that does is it makes it very obvious to everyone who's in the panel that this is a 240-volt circuit and that someone hasn't just accidentally hooked the white wire up to the breaker. Because what are we going to do? We have to connect one of these wires to this terminal and one of these wires to the other terminal. And in the same way down here, at the heater, we now have no confusion over what voltage is being supplied. And you wouldn't believe how common it is for me to see installations where individuals have gone through a panel change and the person doing the panel change did not make note of how many 240-volt circuits there were. There was no phase taping. And so when they went to reestablish all the circuit connections, they looked at this and said, oh, it's a 120-volt circuit, and hooked it up likewise. All right, what about the second one down here? This one's actually going to use subrule 3. And subrule 3 is a little bit different. Instead of using the identified for something other than what it was intended for, we simply don't need it. So this is 143BX, and it happens to be manufactured, or this particular cable that I have, with black, red, and white. It's all I had available, and it was a short length, and therefore I used a cable that was a little bit overkill for the installation. I didn't need that third conductor. And so what does the rule state? The rule states, instead of just sort of leaving it there, what we want to do is cap it or cut it off short. So we would have to cap it or cut it off short. And usually what happens? Well, usually we cap it, right? So cap, insulate, or cut short. And the reason that we're doing this is to prevent inadvertent connection of this circuit conductor to something in the panel board. When you come to a panel board and you see a wire that's just sort of dangling about and something's wrong with the heater, some people's first impression is, oh, well, that wire came off. I better fix it to the neutral bar. And this can introduce problems. So if the conductor is not being used, you have to insulate it, cap it, or cut it off short. So I hope that gives you a little bit of clarity on how we utilize identified conductors with cables in the 2018 Canadian Electrical Code and going forward from it.